Yes friends, today you are going to learn on the divide and conquer technique another algorithms called merge sort. In previous class we have already discussed about divide and conquer and master theorem and bandit search algorithms. Today let us see how we are going to perform the task using merge sort to sort all the element in ascending order and how to solve the examples. Based on that examples, how you are going to write the programs, and thereafter you are going to discuss the time complexity. So let us start with merge sort. Remember that what is a merge sort? Merge sort is technique to sort the elements in ascending order. So what will happen, friends? This merge sort will be perform the task based on the mid element. What will happen here? We are going to divide the array into two parts. We have suppose n number of elements. That n number of elements, we are going to find their array index, minimum index, high index, low index and high index, and divide by 2. That is the mid position it will give you. Okay. Based on that, you are going to divide the array into two parts. So basically we are going to do what? Dividing the array elements based on mid element position, okay, or you can say that index. So dividing the array into two parts based on the mid element positions. How are you going to find out? Say we are having low index, we are having high index, and just we are finding the mid index. Mid is equal to low plus high divided by 2. Okay, so that will be an integer part, right? So we are going to divide the array again and again into two parts until or unless all the elements got separated. Okay, once it is been done, then we are going to merge those divided elements. Okay, based on the comparisons. We are going to compare. So let us see that how exactly merge sort will work. Let us see, this is one of input. How many number of elements we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have n is equal to 8, right? We are talking about the index. Say it is 0 index, 1, 2, 3, 4, 5, 6, 7. In this, what is low index? Low is minimum index 0. What is high index? High index is n minus 1. N minus 1 is 7. Now, what I said, since we are talking about divide and conquer, we are going to divide the array into two parts based on mid element. So now you are going to find out the mid positions. 0 plus 7, low plus high divided by 2. It is 7 divided by 2, nothing but 3. Because you are not talking about the fractional, you are talking about the whole number, that is integer. Right? So 3. We can say that till 3 will be having one array. After 3 we will have another array. So let us see that. 0, 1, 2, 3. It means this part is a left array, and after 3, 4, 5, 6, 7 is another array. It means we are having two functions. One function, say we are having merge sort, we have two parts, we are dividing the list into two parts. In one, we have name of the arrays, we will be having low index, and we can see that mid position, element was 5, 5 is in left side of the arrays, so low to mid. We can, concentrate like this. If our main function is merge sort A low high, then left array will be A low mid. What about the right array? Right array positions, you can see that 2. What is the 2 index is 4. 4 onward means mid plus 1. So second function calling itself will be merge sort A mid plus 1 and high. Look, till mid plus 1 to high, low to mid plus 1 to high. That will happen for each and every iterations until or unless we are able to divide the array such a way that there is no further division is possible. Okay, so let us see in this particular case. Here we have a 0, 1, 2, 3. Parallelly we can solve it. Low index is 0, high index is 3. So 0 plus 3, right? We are going to find out another mid positions here. What will be the mid positions? Mid will be 0 plus 3 divided by 2. Hence it is 1. 3 divided by 2, 1.5, integer value is 1. So 0 to 1, 0 to till mid, 0 to mid position is 1. So 0 to 1 is going to be the left array, and mid plus 1, 1 plus 1 is 2. 2 to high element till last element is going to be the second array again. Similarly, in this part, see here, what is low index here, friend? 4, and high index is 7. So we are going to find out, again you are going to compute mid positions. So 4 plus 7 divided by 2. So it is 11 by 2, 5.5, nothing but 5. So left side of the array, we are going to move till mid position, till 5. So see here, 4 is the index, 4 plus 1, 5 is the index, till mid. And right side of the arrays will start from mid plus 1 to high. So 5 plus 1 is nothing but 6, and to high element is 7. Right. So again, is there any possibility to divide the array's element into two parts? Yes. Here array index is 0, 1. Here is 2, 3. So in next iterations again going to compute mid positions. Mid is 0 plus 1 divided by 2. Hence it is 0. 0 means what? Low index is 0 and mid position is 0. So 0 and 0. So this is 0. Next, mid plus 1. We are going to mid plus 1. Mid plus 1 is 1. 0 plus 1 is 1. 1 to high. High is 1. So it is remain 1. Only 1 elements we have in both, both the arrays. We have 9 and 3. Similarly here, 2 plus 3 divided by 2 is 2. 2 got separated, and 3 to 3. Here 4 to 4 and 5 to 5. Here 6 to 6 and 7 to 7. Now remember that after these iterations, we already having all the elements in each and every sub arrays. We have only one elements. So is it possible to divide? Friend, if you have only one elements, we are not going to divide into two parts. Okay, so we are going to divide the array into two parts only when we have more than one elements. Hence, this complete part from here to here is called divide. This operation is called dividing. Okay, so remember that technique name is divide and conquer. So dividing part we have already performed. What is left? Now we are going to start talking about merging part. Okay, so how we are going to merge it? First you are going to check in these elements 9 and 3. Which is the lesser that will copy at the first place. Say, as for example, this is our resultant arrays. We don't have any elements. We are starting the index from 0, right? See, this is the resultant array of this and this. We are going to compare 9 and 3. Which is lesser? Copy first 3. Then larger element will go towards right hand side, and will keep that index in increasing order. Similarly here it is 7 and 5 will be getting 5 and 7. 5 and 7, right? Now let us see that we are going to compare these elements. Say it is position, it is 2 and it is 3. Now out of this, now we have subarrays 1, subarrays 2. From here we got this and this, right? Similarly in second part, 2 and 4 it will remain 2, 4, and 8 and 6 it will be 6 and 8. Okay, so say here 4, 5, 6, 7 is the index. Now can we perform the task here? Now how it will go? All of you have to concentrate more here. Okay, first we have just creating the space and we are starting the array index from 0. Say this is the resultant array. See, this is the arrays of A of I. This is A of A arrays I position, and this is A array of J positions. Let us see that. We are going to compare A of I 3 with A of J 5. A of 0, A of 2. Which is lesser, 3 and 5? Since this element is sorted, this element is sorted, while you are merging it, compare the elements and which is lesser, you copy it. So 3 and 5, which is lesser? 3 is lesser, put it here. Then once 3 is done, index of first array will increase. Remember that element you are copying to the resultant array, that index will increase. So now this I we are going to increase. So I position is here now. Now you are going to compare 9 and 5. If you are going to compare 9 and 5, which is lesser? 5 is lesser. 5 you copied over here. Then since 5 you copied, index of J will increase. Now J came here. Okay. Now you are going to compare 7 and 9. Out of 7 and 9, 7 is lesser. 7 you copy here as a C of 2. And since 7 is done, then index of J will increase. J came here. Look, we don't have any elements at the new positions. Okay. So this is invalid. J maximum value should be 3. But what is happening? J is going out of loop. So we will stop here. Right. And remaining all the elements from the other arrays, we are copying as it is. So all the elements is copied from the second array. Now let us copy remaining elements of the first array. So we are copying 9. So we can see that these all elements in ascending order. Similarly, when you are dealing with the second part of the arrays, there also you do the same things. Right? First 2 and 6. Which is lesser? 2 is lesser. Copy as it is. Right? As it is. Then since element is copied from first array, right? Element is copied from first array, then I will increase of first array. I is index. Now here you have 4. 4 and 6 you compare it. 4 is lesser, you copy as it is. Now look, in first array both the element is copied. Only we have 2 elements. Hence I pointer is increases. Look, but this array left arrays, we don't have any elements at the I positions. I maximum value must be 5. But we don't have any elements in I arrays after that. Hence, what will happen? It is considered that all the elements of the first array is already copied. Remaining all the elements of the second array you are going to copy. So, in a J loop, right? J, first A of 6 you are going to copy. So, it is 4, 5, 6. And A of 7 you are going to copy as it is. Right? And then again, J will increase till here. We don't have any elements. It will terminate. Let us see that. We have, after comparisons and sorting, we got 2 set of array. One is 3, 5, 7, 9 and other is 2, 6, 2, 4, 6, 8. Now we are going to find out resultant array. Say now this is A and I is index here. This is another A array, I is index here. Now what will happen, friend? We are going to write resultant output. Okay? How it will go? We are going to take as a C as an element. Okay? Now, same things. A of I, we are going to compare with A of J. A of I, we are going to compare with A of J. So, 3 and 2. 2 is lesser. Copy 2 as it is at the 0th index. 2. Since element is copied from the second array, second index will increase. J increases. Now, A of J is 4. Right? Now 3 and 4 you are going to compare. Since 3 is lesser, 3 will copy at the resultant array. Now I will increase. Now 5 and 4 you are going to compare. 4 is lesser, 4 you copy here. Right? Now J will increase. And here index is 3 now. Now we are going to compare 5 and 6 in similar way. 5 you have copied. So I increases. Right? Now 7 and 6, 6 you copied. Hence, J increases. Now 7 and 8 you are going to compare. 7 you copied. So pointer is increases. I pointer increases to last element. Now 9 and 8 you are going to compare. Hence 8 is copied. J increases, but there is no elements. J maximum value is 7. Hence this loop will terminate. Right side of the array will terminate. If right side of the array is terminated, then you are going to check, is there any element is left in the first array? If there is any element is left, then we are going to copy as it is. Here in this case we have only one element. Even we have more elements, we are going to copy as it is. Reason is all the elements in the list are sorted, because from here only we are getting all the elements in sorted order. Hence, while you are copying also, we copy from left to right such a way that resultant array will be in ascending order, and we got in ascending order. Yes, so our final answer is 2, 3, 4, 5, 6, 8 in ascending order, and this is our resultant outcome, right? So this is example. Next is we are going to discuss same things, how you are going to write in the program and how to proceed writing this one by one. Yes friend, as we have discussed the example, same examples we are going to keep it in mind and writing the program. How you are going to write the programs or algorithms? Look, what I said you friend, that we are having the number of elements. Okay, so first you are going to read, okay, number of elements, right? So in main function you are going to ask enter the size of an arrays, enter the size of arrays. Then we are writing address ampersand d address operator n. N means what? We are reading the number of element is n is equal to, as in previous example we have discussed, n is equal to 8. Thereafter, since number of element is 8, now this is our duty to enter all the elements one by one, right? All the arrays elements. So 1 by 1 means what? More number of elements, we should use the loop. For I is equal to 0, I less than n, I plus plus, and scanf is used to read the input address operator a of I. So now we have read those elements one by one. 9, 3, 7, 5, 2, 4, 8. We have read these elements, right? Next is what? We are calling function. What is the function name? Merge sort. A is name of the arrays. A is the name of the arrays. Then look, 0 is our initial index. 0 is our initial index. And what is high value? High is n minus 1. High is n minus 1. So we are writing here a 0 n minus 1. We are passing as a parameter. Once you are passing this and function is calling, it will go and find where this function is defined. So here is the function merge sort a int low. What is the value of low at the beginning? Value of low at the beginning is 0. Value of high at the beginning is n minus 1, that is 7. Okay, n minus 1. For this example, 8 minus 1 is 7. Okay, so basically this is 0, n minus 1. Look, int mid, we have defined it. If low is less than high, what is value of low? 0. What is value of high? 7. Is 0 is less than 7? Yes. Then we'll do this. We have to do when low is lesser than high, then only we'll divide the array into two parts. Otherwise, we will not divide the arrays. As I said, if number of element is 1, low will be pointing to the same place, high index will be at the same place. Say, we have in arrays elements, only element is called 2. If I define the array index, it is 0, and high index is also 0. We cannot define 1 for the same element. Each and every index will have 1 values. So low is 0, high is also 0. So low is not lesser than high. Hence, we are not going to divide the array into two parts. We cannot divide it, single elements. So let us see that 0 is less than 7. Yes. Mid is equal to low plus high divided by 2. We have done 0 plus 7 divided by 2 at the beginning. 0 plus 7 divided by 2. What is the values? 3. And what I said, first arrays will be go from A to mid. A, 0, 3. Second element will be start from A, 0 plus, 3 plus 1. Mid is 3. 3 plus 1, 4. To last element, 7. 4 to 7. So let us see in the previous examples what we did it. Look. 0 to 3 first array and 4 to 7 is a second array, right? So two elements. Because of this we have called one left recursion, and for this right recursion. So we have a two recursive call, right? So these will be repeat again and again. This statement will be repeat again and again until unless all the elements are separated. Means low and high pointing to the same values. Till that moment of time, we are going to divide the arrays. Thereafter, what I said, friend, we are start comparing. We are start comparing and merging the elements based on their values, right? So Once we have done this, then we are calling merge A. Low is a index, initial index. Mid is a mid positions, maybe in individual elements. Whether we are having sub arrays, 4 elements, their mid positions will be different. 8 elements, their mid positions will be different. So we are passing the mid elements and we are passing the high, right? Once we have done this, it will take you to this is, look, this is a function calling itself, right? But here we are calling merge function. So this is another function calling called merge. So let us see that what is there in the merge function. Look, what will happen in merge functions, that I will take that examples again such a way that it will be easier to understand. 3, 5, 7, 9, 2, 4, 6, 8. We have 3, 5, 7, 9, 2, 4, 6, 8. This is the 2 arrays elements we have. Okay. Look, this is one part of the arrays. This is another part of the arrays. And in merge, look, A is the name of the arrays. This is I index. We are talking about the J index. And we'll be having one resultant array that I will talk. A, low is row. Int mid is 3. And int high is 7. In that case, we are defining K is equal to low. K is a resultant matrix for resultant matrix B. Okay, B is a resultant matrix, right? A small a is a arrays here, right? K is equal to low. It means what? K is a pointer. We are defining low. What is the value of low, friend? From the main function is 0, right? So K is low and low is 0. Similarly, what is I? I is also pointing to low. And J is pointing to mid plus 1. Mid plus 1. Here in this case, 3 plus 1 is 4. So see here, J is pointing to 4th. I is pointing to 0. And K is pointing to 0. K is for resultant array. I, J, K. Here name of the array is A. Here name of the array is B, resultant array. Now let us see that how exactly we are going to perform the task. We are checking the condition while I is less than equal to mid. I less than equal to mid. Yes. And J is less than equal to high. J is less than equal to high. Yes. So we have a two condition here. I less than equal to mid and J is less than equal to high. Then only we are going to perform the task. What? This one A of I less than J. A of I 3 less than J. No. A of J is what? 2. A of I is 3. A of I 3 is lesser than 2. Is 3 is less than 2. That is what condition you are checking over here. If A of I less than J. Condition is false. If condition is false, it will go in else part. It is little bit got misplaced. A of 3 is less than 2, no, it will come in else part, and in else part what you are writing? B of K plus plus is equal to A of J plus plus. This is the post increment. So first you are going to assign the values, then will increase. So B of K, B of 0, A of J, A of 2. 2 we have pasted here, and now K increases, K went to 1, and J increases, J went to the next place. So now J value of J is 5 and K is 1. Again go and check. I is less than equal to mid? Yes, because I not increases. Is J is less than equal to high? Yes. Then you perform the task. A of I is less than J. A of I is 3 less than 4. Yes. In that case, you do this. B of K plus plus is equal to A of I plus plus. I element you copy in the B resultant array. So 3 we have copied. K increases and I increases. Let us see that. Is I is less than 3? Yes. J is less than equal to 7? Yes. Now you want to compare 5 and 4. Which is lesser? 4 is lesser. 4 we have copied here. K increases. Hence J increases. Again we will see that A of I I is less than equal to index, yes, mid index. J is less than equal to high index, yes. Compare 5 and 6. So 5 is lesser. 5 you copy, K increases to 4, hence I increases. Now 7 and 6 are going to compare. 6 is lesser, 6 copied here, and J will increase, K increases, right? Now you are going to compare 7 and 8. 7 is lesser, 7 copy here, I increases, hence we have 9 and 8 comparisons. Here A of I is less than equal to mid? Yes, I is less than equal to mid. Mid position is 3, I is 3. I is less than equal to 3. J is less than equal to 7? Yes. So just compare 8 and 9. 8 is lesser, 8 you copied here, right? And K increases to 7 and J increases. Look, J increases, but there is no further index in second array. Hence, this function is terminated. How? Look here. J is less than high. Is J is less than high? No, because value of J in these positions, value of J is 8 and high is 7. So can you say that 8 is less than 7? No, 8 is not less than 7. Hence, this condition is false. If this condition is false and first condition is true, look, it is an AND operator. True and false is remain false. Hence, this complete while statement is false. If this complete while statement is false, then it will come in out of this while. Out of this while. Okay. Now we are here. While I is less than equal to mid. I is less than equal to mid. Yes, equal to mid. Right. In that case, B of K plus is equal to A of I plus plus. It says that whatever the element is present in the first array, you copy as it is into the resultant array. So what is the element is there? 9. You copy it here. Right, and now after this K increases and I increases. Look, K increases based on these statements and I increases. If I increases, now value of I, what is the current values of I? Current values of I is 4 and value of mid is 3. Is I less than equal to 3? No. 4 is not less than equal to 3. If 4 is not less than equal to 3, this condition is failed. Okay. After false, again we are not going to copy. It will come out in the next while loop. J is less than equal to high? No. J is not less than equal to high. It will come out. It means what? We are already done with the sorted elements. Look, what is that? We have to perform the task. This for loop. Reason is our original arrays given in the main function the program was A array, okay, but we have taken one B arrays for our benefit, okay. We have declared it into the merge function. So this is our duty, is to copy these resultant sorted elements into A array. So just writing I is equal to low, I less than equal to K minus 1, I plus. Why K minus 1? Look, K is increased till 8, but you don't have any elements. You don't have any elements, hence value of K will decrease by 1. So we are talking about I 0, K is 8 minus 1 till 7 and I plus plus. 0 to 7, whatever the values you have, right? B of I, B of 0, we have put it into the A of 0, B of 1, A of 1, B of 2, A of 2, B of 3, A of 3. It means what? This B arrays is named as a array. Remaining all the elements will be as it is. 2, 3, 4, 5, 6, 7, 8, 9. Right? And hence this element is in sorted order, in increasing order. So this is what our merge sort function is by using divide and conquer technique. Now what is next? Next is to discuss time complexity analysis. Remember that we are talking about the recurrence relations and earlier concepts also we have discussed recurrence relations, right? And we are going to write this based on the function calling itself. So look what I said you, if number of element is 1, are you going to divide the array into 2 parts? No. Hence we are not going to use the recursive function. So hence time taken to divide single elements is 0. If element is more than 1, in that case what will happen? We have seen that we have divided the array into 2 parts. So maybe one part will take t of n by 2 times, second part will take t of n by 2 times, right? Total time required to sort left side of the arrays, total time required to sort another half of the arrays, right? And plus c into n, c is a constant and n is time taken to divide the array into 2 parts. Time taken to divide the array into 2 parts. So let us see that t of n by 2 plus t of n by 2, can we write 2tn by 2? Yes, plus c into n. So these recurrence relations we have written over here. Okay. Now, if this is the recurrence relations, then as I discussed in the previous class that we have a 2 method to find the time complexity. First, backward substitutions rule, and we have discussed one more method, as you are aware, that master theorem method. So we will see that t of n is equal to 2tn by 2, right, plus cn. So let us see that t of n is equal to 2tn by 2 plus c into n. Remember that t of n becomes this. Then what about this t of n by 2? Is again backward substitutions rule. So can we write this 2 of this t of n by 2 in similar way will be 2t n by 2 divided by 2 plus n by 2 plus c into n. Look, c into n. Look here, t of n by 2, t of n becomes 2t n by 2 plus cn. Apply backward substitutions rule for this part. Replace n by n by 2. If you replace n by n from n by 2, we will be getting 2 times t n by 2 divided by 2 plus, here was c into n, here was n, here was n. Here is n by 2, it will be n by 2, right? Simplify this. It will simplify this 2a square t n by 2a square plus, look here, 2 into 2 into cn divided by 2, 2 got cancelled, again we are getting c into n plus c into n. So that is why we written here 2 into 2 t of n by 4 plus c into n, and these 2 and 2 will get cancelled, we got 2cn in the next iterations. 2cn we got the next iterations. Similarly, now if you are performing the task next time 2a square, now t of n by 2a square, t of n by 2a square becomes 2t n by 2a square into 2, because it is n by 2, it is n by 2, right? So n by 2a square divided by 2 plus c into n by 2a square, this is the n values, n by 2a square, and plus this 2 into c into n original, right? Now simplify this. If you simplify this, what is the value? 2 cube t of n divided by 2 cube plus this 2a square got cancelled, again we will get c into n plus 2 into c into n, right? So basically it is 3cn. So see here 2 cube 3cn. What will happen? Now question is, till when we are going to divide this by 2 by 2 by 2, when will stop? And I said very clearly that we are going to dividing the arrays element again and again until unless we will get the singular element, where further division is not possible. So n is equal to 1, till there we are going to do, and that will happen basically after kth iteration. What is that? Considering that, we have to consider that, as we have written in binary search, consider n is equal to 2 power k. Thinking that power of k, 2 power k is sometimes after dividing again and again, sometimes it will be nearby n. Maybe it will be n or nearby n. If that integral values are 1, then we will stop. Hence, when will happen? When we will get k? See here, third iteration you got 2 power 3, 2 power 3. K iterations, we have to wait for k iteration means 2 power k. So after k iterations, we will be getting 2 power k, t of, look, after k iterations. What will happen? What will happen? 2 power k, t of n divided by 2 power k plus c into k into n. Right? That will get it. So n divided by 2 power k, n and 2 power k both are same. Hence, this value becomes 1. This value becomes 1, t of 1. And c is a constant, so we are not talking about as a part of time complexity. So your focus is in kn or nk. Right? So t of 1 becomes 0. Hence, this complete terms becomes 0. Right hand side we have c into kn. Right? So, if n is equal to 2 power k, then take log both sides. Take log both sides on base 2. What will happen? Log n base 2 is equal to k. So, at the place of k, we can write log n base 2. Hence, n is our original n. At the place of k, we are writing log n base 2. Hence, time complexity of Marshall is t of n is equal to theta of n log n base 2. Okay. So, this is backward substitution rule. Then, one more method I have discussed that is the simplest one is master theorem. Okay. So, master theorem, what will happen? Your recurrence relations must be in this standard form. And as per our example, t of n is 2t n by 2 plus c into n. Now, compare it. What is the value of a? Value of a is 2. What is the value of b? Value of b is 2. Right? What is f of n? N to the power d form. N to the power d form. So, we will compare n to the power d form. What is the value of d? d is 1. b power d, we are going to find b power d, comparison a and b power d. a is 2, b power d, 2 power 1 is 2. So, we can see that a is 2, b power d is 2. It is a is equal to b power d. So, we will go in the second part, and hence time complexity is t of n is equal to theta of n to the power d, n to the power d, and what is the value of d is 1 log n base 2. So, again we are getting the same time complexity t of n is equal to theta of n log n, that is the time complexity of Marshall. I hope it is clear. So, merge sort is again a simple technique by using divide and conquer strategy to sort the elements in ascending order.